Can we use empirical method to better understand the phenomenology of circuit spaces and structures? Until a generation ago, this is a question that would have been anathema to anyone sensitive to the qualitative dimension of human existence, and certainly to most phenomenologists. Yet, Maurice Merleau-Ponty, one of the greatest phenomenologists of the 20th century, seemed to point at the need for a naturalization of phenomenology, that is, a recognition that there is no transcendental consciousness, but rather than all consciousness is invariably embodied and therefore empirically grounded. It is precisely here where today's cognitive science and neuroscience base their claim that, in principle, we can measure the seemingly immeasurable, or at the very least, record the echoes of something perhaps more immaterial or evanescent, such as consciousness. The work and thought of late neuroscientist Francisco Varela loom large here. He's the one that coined the term neurophenomenology to mean that the correlation between human experience and human neurophysiology, or first and third person perspective of reality, are possible scientifically. But much has occurred since his passing, and a whole new world in neurophenomenology is rapidly unfolding, like in the work of Antonio Damasio. And then there is aesthetic cognitivism, a philosophical position seeking to determine concrete and therefore measurable aesthetic responses to art and beyond, as posed by philosophers Gordon Graham and Christopher Baumberger. Aesthetic cognitivism asserts that the experience of beauty is not just hedonic, that is, produce pleasure, aesthetic, about beauty, or expressive, engaging the emotions, but also, and fundamentally, it is cognitive, because it involves the senses and produces knowledge and understanding, which means that it's empirically measurable. We can see a relationship between this development and experimental philosophy, a movement that started in the early 2000s that proposed using empirical means to elucidate all seemingly intractable philosophical questions, such as, for example, free will. There is no denying that the power and relevancy of using empirical means to understand human behavior and psychology have exponentially grown in the world, and that their influence has also expanded in our field of architecture. In the receptive or experiential side of architecture, the remarkable development of evidence-based design is a case in point. It is increasingly necessary to address what we are empirically learning about how building affects human beings. Still, approaching highly qualitative conditions, such as those presented by sacred architecture, has presented researchers with, until recently, a dead end due to the lack of appropriate probing tools. But as the situation has been quickly changing, we must consider this matter seriously. Which brings us back to the question that started this talk. Can we deploy today's most advanced empirical means to gauge empirical experiences associated with spirituality, the sacred, and the like? And if so, how and to what level of success? Now, I would like to share with you a short 4.5-minute video that quickly explains my research work. This will provide the quickest possible overview of my current investigation. I will then briefly share what we have found. Across time, 9,000 BC to this day, across civilization, from Asia to the Americas, the best architecture over and over and over again is architecture devoted to something spiritual. Call it religion, call it, community, call it whatever you want to call it, but it's something bigger than the self, bigger than a person, bigger than even a particular culture.
It's often said that sacred architectural spaces elicit profound feelings of awe, enlightenment, well-being, a connection to the spiritual. Professor Julio Bermudez is deploying modern technology and comparing both sacred and secular spaces to measure and test the cognitive, physiological, and psychological impacts of built spaces.
Once you are trying to understand how architecture works empirically, you can measure things. You first are trying to find some sort of theoretical framework that makes sense. And one of the powerful theoretical frameworks is what is called aesthetic cognitivism. Aesthetic cognitivism asserts that the experience of art is cognitive, is epistemologically productive, meaning it delivers knowledge or understanding, and is empirically testable.
To test this claim, Professor Bermudez recruited a group of 30 Roman Catholics to visit two Washington, D.C. buildings on consecutive days, Union Station and the Basilica of the National Shrine of the Immaculate Conception. Both are beautiful spaces with ornate vaulted ceilings, liberal use of marble and statuary. Both are designed to accommodate masses of people, but one is intentionally sacred and the other is not.
How do you measure human response to architecture with today's technology? That's the question. We start about 100 yards away from the buildings. The subjects are told you're visiting the building, and you're not going to go to mass, or you're not going to go to take a train, but you go to visit the building. The empirical side of it, which is kind of more the medical or physiological part, has two components. One is the brain, which is kind of the most important one, is going to be gauged through ambulatory EEG, electroencephalogram, that measures 20 points of the brain on the electrical activity of the brain. The other aspect of it is measuring the corporal physiology. And this is done with a wristband that measures heart rate, blood pressure, heart rate variability, the electric conductivity of the skin, and a couple other things, the speed of movement and so on. So this wristband allows us to correlate the brain with the whole body, no matter how emotional or how spiritual or how sensual it is fundamentally cognitive. It had to go through, basically your brain at some level.
Alongside these physiological measurements, the team will compare the subject's psychological responses to a set of questions asked during the experience. Professor Bermudez's research team is multidisciplinary, including an architect, a neurologist, a cognitive scientist, a theologian, and an electrical engineer.
This idea of looking at sacred space and understand how is it possible that something like material, organized matter could produce a connection with something transcendental. It's important for a very simple reason, is that when you feel like that, you begin to act in the world very differently. You see the other in a different way. We see, what constitutes development in different ways. Right now, we're about 8 billion people on this planet. And within about 30, 40 years, we're going to hit about 12 billion. Think about that. We're going to build more now than we have ever built. We know the built environment profoundly affects our well-being, and not just personally, but also as a society operates. That for millennia, this was just discussed, but never been able to measure it or to test it. The fact that this is happening is just by itself incredible. That whatever we learn is something we're going to know for the first time in human history.
This is a very simple diagram of the experiment, the design of the experiment. As you can see, we had 30 Catholics believing two conditions. One was the Basilica of the Immaculate Conception, a sacred space, and then the train station, the unit train station, that is, of course, a secular space. We have two type of studies. The one we are really dealing here right now is Project One there, which uses EEG, electroencephalography, and a wristband for biometric signals to measure physiological data, signs, and then also the phenomenological data is how people feel or sense or interpret about the building using a variety of questionnaires. The second project, which we are not dealing with it today, which are in the process of working as we speak, is an eye tracking and physiological data capture along with phenomenological data that using basically mobile eye tracking. I'll talk a little bit about this one at the very end. As explained in the video, the subjects go through a very established path. We have 5 stops. We stop about 3 minutes at each stop to allow for the capture of data and the diminution of noise. This technology has its difficulties, so that's how we deal with it. And at each stop, one about 100 yards from the entry, another one right before the entry, one after the entry, which is a very important moment of transition between the inside and the outside of the building. And then at the main spot or location in the building, both in the Basilica and Union Station, the lobby in one and the other one under the big dome in the Basilica. And then finally exiting the building, which is stop 5. At each stop, after measuring the EEG operation and also the heart and so on, we ask for 5 questions that you see here, using a variety of questions that you see and measure them in a number from 10 to 0. The results, as you can see here, considering the 5 stops, is clearly that the Basilica had people diminishing anxiety significantly. All these are statistically significant results. Also, subjects express a better and high level of aesthetic experience at the Basilica than at the Union Station, much higher connection with the world, others, and God at the Basilica. They experience less everyday thinking at the Basilica. And finally, very significantly, a much higher level of spiritual reality than at the Union Station. Of course, these are kind of common sense responses and findings, but nonetheless, they were important to establish so we could begin to correlate them with the physiological data of the brain and the body. Regarding data processing, in this case of the EEG, the electroencephalography, it was quite an undertaking because of the variety and also the complexity and the amount. So first thing, after collecting the raw EEG signals, they were transformed into frequency, as you can see here, the different beta, alpha, theta, and delta, and gamma, which is now there, a frequency. Then there was a feature extraction that you could see further. Of course, before all this had to be filtered for noise and other artifact removal. That was essential and took quite a bit of time to clear the data before we could go into the frequency and the feature extraction. Finally, we use AI, machine learning, artificial intelligence, particularly the random forest classifier algorithm, to analyze the extraction, the features that we have extracted from the frequency information. This was one of the analyses we conducted, again, using machine learning and AI. The second, in this one, what we have found was, as you can see here, that the gamma frequency was the most utilized by the algorithm to define the difference between the two conditions, the secular and the sacred. The gamma, and the second one was delta band, 16% of the time was used to determine the differences, and followed by 11% by the beta. Gamma frequency is associated with what's called the superconscious, or when we are at our highest concentration level of information processing and learning. This is cognition and problem solving and high level of attention again. Beta is usually our normal conscious state of mind, waking state, if you wish, in which we are operating normally. That includes, of course, anxiety, mind wandering, and relatively active, but also a stressful mind. Whereas the delta one, quite significantly here, had to do with, was associated with deep healing, restorative sleep, and so on. So much more quiet mind. The delta waves, or delta frame frequency, suggest the unconscious mind, if you wish, that is actually more involved, at least for the AI determine determine the difference between the two conditions. So here we have gamma as the most important one, 2/3 of the time, delta 16%, which is unconscious mind, and beta, which is the most waking state of mind, only 11%. The other analysis we used to get understanding from the data was what's called microstate analysis, which I won't describe exactly because it takes a long time. But using this other type of methodology of analysis of the data, we found two relevant or important results. One is that the default mode network, which is the usual state of mind in which we are continuously operating, which involve, as I said before, kind of the beta frequency, if you wish, involve mind wandering, stress, anxiety, and so on. We found that the default mode network in the Union Station was active for longer, much longer than in the Basilica, and also had a greater time coverage at Union Station as compared to the Basilica. Put it differently, the default mode network was disrupted by the visit of the subject of the Basilica. This is quite significant because, of course, as implies that this ordinary state of mind was totally transformed or changed or challenged or disrupted while people were at the sacred space. The second finding we had using the microstate analysis was that the parietal cortex channel, the parietal cortex is the part of the brain that integrates all the senses and therefore important in all kind of perception. We found fundamental differences between Union and Basilica in the theta, alpha, low, beta, and high beta, and the gamma bands, but not in delta. Well, acknowledging the explorative nature of our study, along with its limitations, I can offer a provisional interpretation of these results. One, the Basilica induced a higher state of attention, that is the gamma band, in the subjects, something consistent with Catholics being presented with an environment filled with much religious information, both symbolically, that is artwork, science, and architecturally, that is space, form, materials, light, that is strongly communicated to them and therefore demanded their attention. Two, such a high level of attention commanded by the Basilica on the subject is consistent with a shorter duration and lesser deployment of the default mode network relative to Union Station. Three, the reduced internal dialogue, less anxiety, a greater sense of connectivity, elevated aesthetic appreciation, and heightened awareness of a spiritual reality elicited by the sacred building suggests that study participants may have experienced a contemplative and pleasurable state. This pattern of responses align with the previously demonstrated neural correlates of meditation and contemplation. And finally, four, the increased attention of the parietal cortex of the Basilica suggests a stronger level of sensorimotor integration in sacred versus secular conditions, which is consistent with aesthetic arousal and an overall high level of outward directly attention, that is, attention directed by architecture and art, as well as a lessening of the operation of the default mode network and a higher activation of the gamma frequency. This is very quickly to show you what we are working right now. We're using mobile eye tracking technology and biosensor to look at the causes of the effects that we just observed. In other words, we are looking at what is it in the building or in the art that is causing people to get into these states that we have just measured through EEG and biometrics. For that reason, we are using what is cutting edge, the last generation eye tracking, which is able to locate the gaze of individual as they walk through the building and engage the building directly. We produce, as you can see on the bottom right hand of the screen, the path of the gaze, which is where people are looking, but also maybe more importantly, what's called heat map, a statistically significant location where all the subject as a whole pay attention in the building. with this, again, we try to understand the causes where architecture is communicating and how so to individuals. As said in the video, our work is being conducted by a highly interdisciplinary team. You could see that includes neurologists, psychologists, theologians, computer scientists, and also a series of research associates dealing with all kind of activity, from the processing of the data through statistical analysis to conducting the study itself, to AI, algorithmic, and so on. If you are more interested on what we are doing, please visit our website that includes all the information and more you could find there. Thank you for your attention. And if you have any question, please, you know where to find me. Send me an email and I'll respond.